Hi, everybody. This is Justin at the Extension Office here in Barber County. I'm going to walk you through a little bit today on hopefully understanding forage analysis a little bit better. I'm just going to give you a little heads up. The computer I'm using is rather small with the camera, so I'm going to be looking to my right at a little larger screen, so don't be confused or anything like that. So right here on the screen is a sample of an example of a forage analysis report. Sometimes these things can be a little overwhelming, especially when we're talking about as fed or dry matter or acid detergent fiber. Some of these terms might not be familiar to you. So that's what this presentation is all about, is we're going to discuss the basic analytical procedures and hopefully define some of the more common terms that are used with a forage analysis. When we're evaluating forage quality, the absolute best method for evaluating the quality of any feedstuff is simply feed it to an animal or a group of animals maintained in a controlled environment, and then simply record the performance of those animals. Now, this would take a tremendous amount of time and it's awfully expensive. So a laboratory analysis is an economical means of gathering data which may be used to reliably predict animal performance. When we're evaluating forage quality, we want to look at qualitative, which we're talking about the color, the leafiness, the smell, the texture. That also includes dust, mold, foreign material. And we also have the quantitative, which is the analysis conducted in the laboratory. There's a couple methods that we use. There's a direct and indirect, and we're going to discuss those a little bit further in the presentation. So about 80% of what you're going to want to know on a report is broken into basically four components. We got moisture, and we're talking about on moisture is dry matter and as received. We got total nitrogen, which is used to calculate the crude protein. We got ADF, which is acid detergent fiber. This is used to calculate various estimates of energy that are commonly used, such as TDN, total digestible nutrients, or net energy from maintenance. And then we got NDF, was the neutral detergent fiber, which is used with the ADF to help calculate the relative feed value, or RFV. On moisture or dry matter, this is the simplest analytical procedure, but it is the most important because all other nutrients are reported on dry matter basis. So the dry matter is used to calculate all the other values on analysis. Secondly, this analysis allows us to compare some very different feeds, such as silage to straw. The procedure is relatively simple. They're going to put it in a forced air oven at 100 to 105 degrees C for 24 hours on a dry forage or a hay. When we're looking at a wet forage or fresh clipped silage, it's a two-stage drying process where it goes to the forced air oven at 55 degrees C, and then we raise it on up to the 105. And the reason we want to do that is it minimizes the amount of nutrients that could be lost in that drying process. Crude protein is determined by measuring the amount of nitrogen within a sample. There's a couple methods that are used. The Keldal analysis, which originated in Germany, and that goes back well over 100 years. But the most commonly used today is total combustion. They take a small sample, they'll place it in the machine and have it burned. The gases are produced and collected, and the amount of nitrogen produced is evaluated. This is very rapid, approximately 4 minutes per sample. On detergent fiber analysis, we have NDF and ADF. That's a neutral detergent fiber and acid detergent fiber. These are just two components of the fiber detergent fiber system. This was developed by Dr. Van Soos at Cornell University. And basically it partitions plant samples into two fractions: the cell wall contents, which are highly digestible, and the plant cell wall, which varies in digestibility. Down here on the bottom, you'll see this was developed to replace crude fiber. Crude fiber tends to underestimate the cell wall content, but we're still seeing that today on bagged feed, and you'll see the crude fiber on a feed tag still today because that is the legal standard. When we're looking at the plant cell wall components and the detergent fiber system, just keep in mind NDF, the cell contents are going to be removed, and it's going to measure the amount of hemicellulose, cellulose, and lignin. And this will be correlated with the animal intake. On the other side, you got acid detergent fiber, or ADF. This is going to remove the hemicellulose. It's going to measure the amount of cellulose and lignin. Now, lignin's fairly indigestible, so ADF will always be correlated with digestibility. Just keep in mind on a report, the higher the number is on the ADF, the lower the digestibility will be. On energy estimates, there's several different terms that may be used to express the energy content of a feedstuff. The two most common are TDN, total digestible nutrients, and net energy system, which is further divided into net energy for maintenance and net energy for production. Total digestible nutrients, or TDN, this has been around for well over 100 years, and it's the most common term, or it's the one that you may be the most familiar with. It is a calculated value that's essentially the sum of digestible protein, carbohydrates, and fat. The fat content's multiplied by 2.25 because fat contains 2.25 the amount of energy as carbohydrates. As the name implies, it's only going to account for fecal losses, so sometimes or often it's going to overestimate the value of the forage. The net energy system, this more reliably predicts the feeding value of feedstuffs as it accounts for the energy associated with feces, urine, gas, heat production. An animal fed at maintenance is going to use energy within a feedstuff very efficiently. So if you're looking at the little graph here, that line is going to be a little bit steeper than an animal that's being fed to gain weight. On the screen here is just a sample of some of the many equations that are going to be used by a lab to calculate energy estimates. The most important thing you want to know about this is there are different equations for different types of forages and feedstuffs. So this is one of the most important reasons why you want to label your sample correctly. You'll see an equation for legumes. You'll see an example for mixed forages. So if you got a sample of alfalfa and you got a sample of grassy alfalfa, you want to make sure you label those accordingly. Relative feed value, or RFV, is not an energy estimate. It's essentially an index created to rank alfalfa and has no specific units or meaning associated with the term. So this table here illustrates the relative changes that occur in crude protein, ADF, NDF, TDN, and RFV that will occur as maturity of alfalfa advances. So as we notice here on the screen, from bud to full bloom, the crude protein is going to reduce, the ADF is going to increase, and the TDN and RFV will decrease. Relative forage quality, or RFQ, this was developed as an improvement over the relative feed value as it uses the total digestible nutrients rather than the digestible dry matter. This can be used on both legumes and grasses, but also has no specific meaning as it's just simply an index that may be used to compare forages. On a NIRS analysis, this is a rapid analytical procedure that's offered by many commercial labs, and most of the time it's the cheapest analytical package. So the basic concept of NIRS analysis is illustrated right here on the screen. The data used to generate the equation is typically generated from values obtained by wet traditional chemistry methods analysis. So they're going to send this infrared light into the sample. Whatever the reflected light is going to be collected on the detector cell. And that relationship between the amount of reflected light and the analyte is used to determine the concentration of the analyte in the sample. This slide here, we're going to attempt to put a value on forage testing. And in this example, we're just going to use two forages that are simply 1% different. So if we got a 1,400 pound third trimester cow, she's consuming 2% of her body weight, that's going to be 28 pounds. We're going to multiply that 28 pounds by 7%. We're also going to multiply it by 6%, then subtract those two numbers, and we're going to have 28 pounds or 0.28 pounds crude protein per day. So when we go to look at our supplement, we'll plug in that 0.28, divide it by 20%, and that's going to give us 1.4 pounds of 20% supplement per day. We'll then take that number, multiply it times 60 for the amount of days fed. That's going to give us 84 pounds of supplement. We'll then take the price of our feed. In this example, we're just using 400. Keep in mind that number is going to change depending on what you're paying for it. This is just an example. You divide 400 by 2,000, multiply it by 84, you've got $16.80 per cow. So what does all this mean? This example is geared to if, say, you don't have your forage tested and you're guessing that your forage is a 6% crude protein, but it's actually a 7% crude protein, you're losing money. For the amount of money it costs to feed per cow, the $16.80, you could have got that forage tested, known exactly what you had, been a little bit more efficient and saved a little money. On this last slide here, we're just basically looking at a couple forage analysis. In the top example, this is just a native grass hay, and in the bottom sample, this is a Bermuda grass hay. So I would encourage you, don't get locked in on that crude protein number right off the get-go. Come on down a little farther and let's look at the ADF compared to both of them. And then let's look at the net energies compared to both of them. Keep in mind, this is not alfalfa, so we're really not concerned about the relative feed value. When we're looking at these two, they're fairly comparable. And I'd go as far as saying they're both good hays. They're not great, but they're good. So if we're looking at this hay in our supply right now, I would say that you could feel comfortable with your third trimester cow with this weather that we're having, feeding this top sample of grass hay, this native grass hay, even though it says it has a crude protein of 5. When you really look at the ADF and the net energy components, it's still a good hay. Not great, but good. If you're using some supplement, you're going to be just fine with this. And the reason I'd say you can go ahead and feed that right now is maybe you save the Bermuda grass hay, which does have a little bit higher protein. It's just a little bit better in the ADF and just a little bit better in the net energy numbers. You can save that until after she's calved and use it at that point. So if you have any questions, feel free to reach out to us at the extension office anytime. You can call or email either one. Have a great rest of the day. And remember to be safe out there. It's pretty treacherous with the weather. We want to be taking care of our livestock, but we also want to be taking care of ourselves.